All right, new section of material, chapter 3. We're looking at 3.1 here, and we're going to take a look at statements and quantifiers. Okay, that's where we're starting. So again, there's a good portion of this, especially, in fact, most of this, you're going to feel like, that doesn't really feel like math. It's okay. It is a branch of mathematics. It's called logic. We also do this in philosophy classes and in critical thinking classes on campus. So if that's a field that you're going to be taking some more classes in, you might see some overlap. If you're in education, you're going to do elementary education or special education, early childhood, those kinds of things, you'll see some of this show back up in there again as well. So there's some places you're going to see it again. So to start with, our leading idea. Statements and quantifiers in mathematics help us express ideas clearly, whether something is true for all cases or if there exists at least one example. Faith in God in a similar way involves believing in truths that apply universally, as well as personal experiences that confirm those truths individually. Just like quantifiers give us precision to mathematical logic, faith uses broad and specific understandings to shape how people make sense of the world. We're going to pray. Dear Heavenly Father, I thank you for this opportunity to have a fresh slate today, to have new material, a chance to set the score straight and to start with something new. I pray that you would help all of us to be aware and attentive in class today and be able to take away what we need from this material. In Jesus' name I pray. Amen. All right, so a little bit of vocabulary to start with. A statement. A statement is a declarative sentence that is either true or false. For example, I ate cereal for breakfast. You can say true or you can say false to that. It's absolutely one or the other. That makes it a statement. There are several kinds of sentences, we will say, that are not statements. Okay? So one of those is questions, right? If I said, did you eat cereal for breakfast? That's not a true or false kind of a response. It doesn't make any sense to do that. That's not a statement. Another one is a command. This is what I would tell my daughter if she's dawdling at the table, eat your breakfast. Right? That's, again, you can't say true or false to that. It doesn't make any sense to do that. Right? So that's not a statement. There's a couple other types of things that are not statements. This particular curriculum doesn't really focus too much on that. It kind of falls in one of those categories, right? Commands and questions or statements. So we're going to decide for the first couple of examples whether we have a statement or if we do not. So the first one says, yield to oncoming traffic. Is this a statement? No, this is not a statement. Right? It's actually a command, but it's definitely not a statement. How about 1 gallon of milk weighs more than 4 pounds?
It's not a statement.
It is a statement. It is a statement because it's either true or false. Now, just because it's not true or it's not false doesn't mean it, but it's one or the other. Okay, now you may not know the answer. I'm not necessarily sure that I know the answer. I've picked up the gallon of milk, but I don't know. I'd have to look it up. But it is true or false, right? Does that make sense? So this one is a statement. Now, there are some examples of things that it's not possible to know whether something's true or false about. For example, I can say I ate cereal for breakfast, but if I say she ate cereal for breakfast, we cannot possibly know if that's true or false because we'll know who she is. Are you with me? So there's some of that too that's a little bit ambiguous. It shouldn't come up in any of your things, I don't think. If I'm mistaken, you can let me know that. But that is an example. Another example that doesn't seem to come up in this particular curriculum, but it is coming in another curriculum that I use, is opinions. I love eating cereal for breakfast. Well, that's not a true or false statement. That's dependent upon the person who's saying it, right? It's their opinion about something. So that's actually not a statement either. Again, I don't think that comes up in yours, but it is definitely not a statement. Compound statements. Compound statements are formed by combining two or more statements. And you combine them with items called connectives. So connectives are used when forming compound statements. Some of the ones that we use in this class are and, or, not, but, if then, there are others. But there's actually really only 3 types. We'll get down to what those 3 are, even though I've given you a list of different kinds of connectives here. They really all fall into 3 different categories. So there's going to be something that takes 2 statements and joins them together in some fashion. That's what it takes to be a compound statement. So number 3 says, well, directions say for these anyway, decide whether the statement is compound. So you're not deciding if it's a statement. They're telling you it is, in fact, a statement. You're just deciding, is it a compound statement? So number 3 says, if Tom is a politician, then Jack is a crook. Is it a compound statement? It is. This is compound. Tom is a politician is one statement. Jack is a crook is a separate statement. And it's being joined with if then. So this is, in fact, a compound statement. Hey, Mark, would you get that back door for us so that we're not disturbing them and they're not disturbing us? Thank you. How about tomorrow is Wednesday? No, it's actually true, though, isn't it? Tomorrow is Wednesday. So this is a statement, and it's true, but it's not compound. Because there's only one statement there. There's not 2 that are joined. Jeremiah.
So to tell if it's a compound statement, we have to see if they're using the wording like if, and, or not.
That's one key phrase, yes. And that's usually the simplest thing to look for is to look for if one of those connectives is present. Clearly, there's not a connective present in tomorrow is Wednesday, right? But definitionally, right, like we can also see that there's also not 2 statements there at all, but there were 2 statements on the last one. So you can think of it from either perspective. Okay, any questions on compound statement sort of forms? We're going to talk a lot more about them later too.
If one's a statement and then one's not, it's not a compound statement?
Correct. Like, I don't think you're going to see anything like that, Neely, but let's say it said, if Tom is a politician, then what is Jack? Right? That wouldn't work. Right? That's definitely a sentence. It's definitely compound of some sort, but it's not a compound statement. So yeah, that's a good question. All right. Negations. Negations are the logical opposite of a statement. Sometimes they're really easy to do, and sometimes they're not so easy to do. So we're going to start with one that's easy to do, and it's a statement that I already made before. I ate cereal for breakfast, which, by the way, is false. I didn't do that, so. Okay, so if that's my statement, the negation needs to be the logical opposite, the exact opposite of this statement. What is the logical opposite of I ate cereal for breakfast? Yeah, you just put the word not in, right? Pretty straightforward. I did not eat cereal for breakfast. So some of these are just really, clear. The ones that are not clear are the ones that we're about to talk about. Okay, so the ones that are clear, you either put the word not in or sometimes you take the word not out, right? If the original statement said, I did not eat cereal for breakfast, then its logical opposite would be, I did eat cereal for breakfast, right? We're not going to say I did not. We're not going to do that or anything like that. No double negatives. But quantifiers are what make things difficult. So let's talk about what quantifiers are. Quantifiers are the words all, each, every, no, none. These are called universal quantifiers. And then there's words that say something like some, there exists, and for at least one. And these are called existential quantifiers. And it's exactly when these are present that it's more difficult anyway to create negations. So jot those down. Universal quantifiers are the ones that generally, they're generally false when we use them, to be honest. They're statements that go something like this. You always slam the front door. You never remember to take your shoes to your bedroom. They feel accusatory a lot of times. But specifically what they're doing is they're using a word that indicates that 100% of the time, this is what's happening. That's just not usually the way things are, right? You probably don't always slam the door. And there's probably that one time when you did remember to take your shoes to the bedroom or whatever, right? So those are the universal ones, the ones that say it's always this direction. 100% of the time, this is what happens. Existential quantifiers is what happens most of the time when you respond to somebody who's accusing you of a universal. Yes, I did. Do you remember that one time 3 months ago when I came in and I was really happy and I closed the door very nicely? That one time. All it takes is that one time. Something that makes it not 100%. Yes, I did take my shoes to the bedroom. I did it last Tuesday morning. I took them to my bedroom after you got mad at me. Something like that. All it takes is that one time, okay? So existential quantifiers means it happened, but maybe it only happened once. That's why you see it say for at least one. Well, maybe it's just one time. Universal quantifiers means it has to happen 100%. Now notice, what it takes to sort of make it the opposite of the 100% is it exactly takes one time that it doesn't happen, right? It doesn't have to mean that you never did it. So we don't go back and forth between always and never. We go back and forth between the always nevers and the one time when something happened, right? That one time that makes it not 100%. So when we're taking a look at something like this, we're going to write a negation of this statement. So this statement says, some books are longer than this book. Do you see the quantifier that's being used? Some. What kind of a quantifier is that? It's existential, okay? It indicates that there's a portion of, a percentage of, that's not 100%, correct? That's what makes it existential. And here's the deal. Anytime you've got an existential quantifier given to you, and you're doing a negation, it's going to become a universal quantifier. So if starting out with some, it needs to turn either into all or none. And you sometimes have choices too. Like it could be either direction and it makes sense. Usually there's one direction that sounds a little bit more linguistically like the way we speak. Okay, so I'll write both of them down here. But if it starts out existential, it becomes universal. And if it starts out universal, what do you think is going to happen? It's going to become existential when I do the negation. Okay, so here's this one. It says some books are longer than this book. So I'm going to do both the all and the none so you can see how they sort of pan out. What you'll see happen, I'm pretty sure in my math lab, is these are multiple choice. Okay, so one of them will probably be present in the multiple choice list and probably the other one's not. So it's not like you're going to have to decide between two equally good opportunities, right? One's going to be right and one's not, or multiple ones are not, more than likely. So we're going to do the all, and then we're going to do one that says, it won't say none, it'll say no books because that's proper grammar. So it's going to be all books and no books. So let's do the all books first. Okay, so if we take some and we turn it into all, did we negate it? Did we make it the opposite? Careful. No. We made it, right now, that's all we've done so far, a stronger statement. Some are, all are. Some of the time you do this, all the time you do this. We didn't negate it, we made it a stronger statement. Y'all with me? Now, that doesn't mean we did anything wrong, it just means that we still have to do some negating later on in the problem, later on in the sentence. So if I changed some to all, I'm going to have to include something about the word not later on. I've still got to create the negation part of it later in the sentence. So if I've got some books are longer than this book, I'm going to change it to all books are not longer than this book. Now I know it's really tempting to change it to say shorter. You're not going to see that because that would exclude the possibility of them being what? Equal. True? So when we see this happen, you're going to see them using the word not and keeping the rest of the phrasing identical. So we're not going to change the phrasing. We're either going to put in a not, we're going to take out a not, but we're not going to change the words themselves, okay? This would be a negation. Some books are longer than this book. All books are not longer than this book. Let's just say for now, that's a little awkward wording. That's not how we would actually say that statement. The next one's more natural, so let's check it out. If I change some into no or none, have I negated it? Yes, I have. Okay, so if I change some, which means it does happen, at least, like 0.5% of the time, and now I say none, then I'm saying it doesn't ever happen. That is opposite. That is negating that possibility already. So that means that the rest of the statement gets to be rewritten just as is. I don't have to change anything else. No books are longer than this book. That's what's wrong. Okay. Does that make sense? Both of these are correct changes. They're both right. One of them will be present in the drop-down, multiple choice options, and one of them won't. But I don't want you to be like so set in your mind on that second one's a much better solution, and it's not there, and now there's not a right answer. There's a right answer. It might not be the one that you wanted it to be, but this would be one way to change it. Okay? And both of these would be negations. Another thing that you're asked to do is do some negations where we have some inequalities. So this says give it a negation of the inequality, and it says do not use a slash symbol. So we've seen slash symbols used. What that means is that they're not telling you to do, or they're telling you not to do this. Technically, if you do that, it actually creates a negation. It is a correct statement, okay? Like that would be the negation, but they're not wanting you to do it like that. That's what the directions say. They said, I want you to do this, but not like that. So what would be the opposite of x is greater than or equal to 5? X is less than 5. Notice, it doesn't say less than or equal to, right? The equal to is going to be on one of them and not the other. So if they had started out without the equals, your answer would have it in it. If they start out with the equals like ours did, your answer doesn't have it in it. We're trying to cover everything that it's describing that doesn't satisfy this criteria. In terms of this is like a number line perspective, perhaps you've seen before. Looks like this. And what we're saying is that there is a number 5 on here. And part of the values, the ones that they're giving you to start with, say I include 5 and I go everything bigger. That's over here. So the opposite of that would be not including 5 and going everything smaller. That's the answer that I'm getting down here. Okay, so it's everything that doesn't include 5 and is smaller. All right, there are 3 general types of connectives. Right, we talked about lots of verbs or lots of ways that you can see them used of connectives before, but there's just 3 categories of them. One connective is the and connective. You also see the word but in this category. So if you actually use the word but, it means the same thing as and. It just has this English connotation to us that says these are sort of contradictory statements, but they're both true, right? That's what the but's doing for us. And they're both true. So but and are the same thing, all right, in terms of the structure. Or is another one. And then the third one, we've seen this one already as well, is the if-then. We're going to add another line to this where it's not actually a connective, but I want you to have it in this sort of symbols area, and this has a lot of symbols. I'm going to use the word not down here. It's not really a connective, but it does have some symbols for it, and so if I have it in the same list, it kind of makes sense. All right, so let's look at symbols. Okay, so do you remember doing, I know you do because it hasn't been that long, intersections and unions? Yes. Everybody remembers those? Okay. Intersection had the connotation of the word and. Do you remember that? This and this, right? It's in my husband's family and in my family. It's the place where they cross and it's the intersection of the street, right? It's true for both things at the same time. It's an and. The and works the same way here. And do you remember what the symbol was that we used for and? It was an upside down U, okay? This one has the same feel to it. It's actually an upside down V. Okay, so they have the same opening direction. If you don't want to remember any of that, you don't have to remember the intersections and unions. You can just start from here too, it's okay. Or corresponds to what we did with unions, where we got the whole family picture, right? My family or your family, right? And so with the or, we used the U for the union symbol. And so we're going to use a V for the or symbol here. So it's opening upward, just like our U opened upward, our V opens upward. If then actually uses an arrow. And not uses a tilde. Okay, this is not exactly in your box, but it is the symbol. And these kinds of statements have names. So the and statement is called a conjunction. An or statement is called a disjunction. An if-then statement is called a conditional. And we've already talked about the not one. It's called a negation. We did negations, right? We just didn't introduce that symbol before. So that negation symbol is a tilde. So the first thing we're actually going to do is practice kind of turning our words into symbols and our symbols back into words, get a little bit more comfortable with the notations and how they're used. So our first example is we're going to let P be the statement, Leah is a teenager, and Q be the statement that Joe is a lawyer. And we're going to translate these symbols, because we've got some symbols here on number 7, and we're going to put them into words. Okay? So the symbols are kind of like what we do in algebra where you're using like representation for variables. It's like that kind of an idea. It's just taking something and it's replacing it for that statement. So the first one says that Leah is a teenager. And you see the P showing up right here, correct? Okay. So it still means Leah is a teenager, but what does it mean if I put the little tilde in front of it? Not. I mean, it means it's a negation statement. It's a not statement. So instead of saying Leah is a teenager, we're going to say Leah is not a teenager. So that's how it's going to start. So Leah is not a teenager. So the next thing we encounter is this upside down V shape. What do we say that actually meant? And. So we write and. The next thing we have is a Q. And this Q right here says it's supposed to be Joe is a lawyer. And there's that Q right here. So ours won't say Joe is a lawyer. What will it say? Not. Yeah, because there's tilde, right? So we're going to say Joe is not a lawyer. It's not written very well. That's better. Joe is not a lawyer. Okay, so this takes symbols, puts it into the letters, okay, or in the words. So again, you're going to see this probably showing up as a multiple choice kind of a statement, right? They're going to give you these pieces. They're going to give you some options. Some things are going to change correctly. You just need to make sure that you're getting the answer choice that changes every single piece or represents every single piece that's in the statement. This one does not tend to show up as multiple choice. It tends to have the opportunity for you to enter your answer as is, okay? So we've still got the statement, Leah is a teenager, Joe is a lawyer. But what we're doing now is we've got a sentence given to us and we're going to turn it into symbols. So the first piece says, Leah is not a teenager. How do we write the statement in symbols? Leah is not a teenager. It negates P. Make sense? Okay, the next thing we have is the connective or. What do I do for the or connective? It's a V. And then I have the statement, Joe is a lawyer. That's Q. So we've got tilde P or Q. And you can see why entering that as opposed to entering a sentence is the way that they would set that up, because they have less coding to do on making sure you didn't like spell somebody's name wrong or put a comma when you shouldn't have put a comma, right? It's just symbols. And there is a tilde symbol both on the keyboard and there's usually a symbol pad too that you'll be able to do that with. And the V is not the V on your keyboard. There will be a symbol pad for the appropriate V as well. I should probably make mention of that in case you're accidentally using that V. We're talking about it looking like that, but it's not the actual letter V. Okay, a little bit more in this section before we move to next section 3.2. We're going to decide whether each statement involving a quantifier, so remember quantifier means it's going to have those universal, like big time 100% statements, or existential, it means there exists at least one of these times when such and such happens. And so we're going to decide if the statement is true or false. Now here is one place where this is going to push back into some prior knowledge, and not necessarily prior knowledge from chapter 2, although we did it in chapter 2, but prior knowledge from high school. I mean, that's where this is going to push back into. So it might be something where you have to look a few things up along the way because you just might not remember. And if so, just do that, okay? So all irrational numbers are real numbers. Now, I did do this one in class. We drew a diagram. It was a big rectangle, and I split it into boxes, and there was boxes inside of boxes and things like that. Does anybody remember, is this statement true or is it false? Are all irrational numbers real numbers? They are, actually. Yeah, it's a true one. So, and the picture, I'll give you a reminder as the basic picture. The basic picture that I drew looks like this. It didn't look like that at all, actually, because that's not what we have. How about a rectangle? And I split it into pieces like so. And the whole box, the entire box that I drew originally is the real numbers. And this piece over here were the irrationals. So we had rationals on one side, we had irrationals on the other side, but it was all inside of the all-encompassing, world of real numbers. Okay? So this one's actually true. How about the next one? Each whole number. Okay, so each is another statement as all, right? These are also, they're both universal quantifiers. Each means 100% of them. Each whole number is a positive number. That is false. It's almost true. What makes it false? 0. Zeros are a problem. It's the one thing that doesn't work. But how many things does it take for it to not work? 1. It takes 1, and we've got it, so this is a false statement.